In this lesson, we're going to discuss definite integrals. Just to note that the integration in this video is going to be limited to very simple power rule, natural log of x, and e to the x rules. The definite integral of f of x on a closed interval of a to b is denoted as the integral from a to b of f of x dx, where a and b are called the limits of integration. This is different than what we had done in our previous lesson, which was looking at the indefinite integrals. An indefinite integral is really just an antiderivative. Our answer that we get is a function. The definite integral here is going to give us an actual value, and that value can be representative of the area under the curve of f of x. The fundamental theorem of calculus is what we can use to evaluate these definite integrals. So if we're given a continuous function, again on a closed interval of a to b, and we know that the antiderivative of f of x is given, then the integral from a to b of f of x dx is equal to the antiderivative of f of x evaluated from a to b. And we evaluate that by finding the function value of my antiderivative at b and subtracting the antiderivative evaluated at a. So in the next three examples, we're going to look at finding these definite integrals, and if necessary, we'll round. So here I'm looking at the integral from 3 to 5 of 2x minus 7. The very first step is to find the antiderivative. The antiderivative of 2x minus 7 is x squared minus 7x. I wanted to now evaluate that from 3 to 5. So I start by evaluating this antiderivative at 5. So I plug in 5 in for x. Then I subtract that from what my function value of the antiderivative is at the value of 3. I end up with negative 10 minus a negative 12, which gives me a positive 2. In this next example, we have an exponential function to find the antiderivative of. So I have the integral from negative 2 to 0 of e to the negative 2x dx. The antiderivative of that function is e to the negative 2x divided by negative 2, and I'm evaluating that from negative 2 to 0. So I start by plugging in 0, since that's the larger of the two numbers. We always go with the larger number and then plug in the smaller number. So I have e to the negative 2 times 0 over negative 2 minus e to the negative 2 times negative 2 divided by negative 2. So in our graphing calculator here, you can do this all in one step if you want, but I know e to the 0 is just going to be 1. So I have a negative 1/2 here, minus this is going to be e to the positive 4 divided by negative 2. And I get about 26.7990750. Rounding that to 3 decimal places, well, 0.799, that's just going to be 0.8. So 26.8 is my solution. Our last example here, we have the integral from 2 to 7 of 6 over x dx. Well, whenever I have a constant over x, that's going to be my natural log as my antiderivative. I'm evaluating from 2 to 7, so I'm going to plug in 7 and then plug in 2 and find the difference between those two values. So 6, the natural log of 7, minus 6, the natural log of 2. You could also take your antiderivative by pulling out that 6, factoring that out, and then finding the difference between the natural logs. It really doesn't matter. It's just a little extra typing. I get 7.51657, which is 7.517. In our last example, we're going to look at an application. So production costs of a new machine grow at a rate of 200 the square root of t dollars per week. Find the total production cost during the first 4 weeks of production. So in previous weeks, we've had a problem like this, but I would ask you to find the total production cost, say in week 2. I would give you one specific week. So what we would do is we would find the cost function by taking the antiderivative of this rate, right? Because this rate here, this 200 the square root of t, that's my instantaneous rate of change. That's my first derivative. How do I undo a derivative? I take the antiderivative, or I take that indefinite integral. Now we have the tools to find production costs during a larger range of time. So I can find this cost during these first 4 weeks of production by using the definite integral. So I'm looking at the integral from 0 to 4, those are my first 4 weeks of production, of 200 the square root of t dt. Taking the antiderivative, I get 400 over 3t to the 3 halves. I'm evaluating that from 0 to 4. We plug in 4 first, then we plug in 0, and we get approximately 1066.67. Now I rounded to 2 since we are talking about money here. So the total production cost during the first 4 weeks of production is $1,066.67.